This lecture is 1.2, talking about function notation. And in that first paragraph, they give us a little bit of a definition that for every x, there's to be exactly one y. Every input produces one output. Very important. So in that first example, if you look at them, just kind of scan them and see if you think each one is a function. The first one is a function. The second one is not. And the reason why the second one is not is there's this 8, and as an input is being mapped or sent to 2 and 0. So when you're dealing with functions, you want one input, one x value to go to only one y or one output. In the box, you can read some of the characteristics. When they talk about set A or B, they're talking about A is the input, B is the output. So you're going to pause the video, do the example 2, which are the DIYs, and then come back and look at the answers. Okay, the first example is a table, inputs, outputs. Nothing repeats in the input list, 0, 1, 2, 3, 4, so then there's no way that it could not be a function. In the part B, they're graphing what looks like a parabola, and there, even though some of the y values are the same, none of the x values, if you listed out all of your dots or points, all of your x's would be different. And then finally in part C, they use the arrow method, and this is not a function because of the -1. So let's take a closer look. The -1 is being mapped to 3 and to 4 like we saw above. This is not good, so no, this would make it not a function, which is different if you look at the -2 and the -1. So we have two different inputs. If they were just mapped to 3, like the arrows show, they go to the same output, that's okay. It's when one input gets split. So be careful when you determine that. On the second page, we start looking at what is called the vertical line test. Probably the easiest way to solve or determine function or not a function. You're going to get a picture of the graph and draw vertical lines. So if I start drawing vertical lines, I can draw one here and here, here and here, and we're okay. We're only hitting our graph once with each vertical line. So for that particular x, there's only one output. If we zoom in on the one where that's a solid dot, and then there's that open dot. Now when I draw my vertical line, remember that the open dot represents you're getting close to that spot, but you're not using that point. So it's hitting the closed and then going through the open. So this would continue to be a function. So this is a yes, it is a function. So in this next example, we're going to look at graphing some of these and seeing what happens with the picture. So to graph these, we're going to need to do a y equals equation. So simply move your 2x squared over here, and you have y equals 4 minus 2x squared. So I can go to my graphing calculator, and I can type in the equation y equals 4 minus 2x squared. And if we look at the graph, you can see we have an upside down parabola. And with an upside down parabola, we're going to be able to draw vertical lines over and over and only hit once. So yes, this is a function. So at this point, you probably can just say, if I run into a parabola, an x squared graph, I'm going to be able to say it's a function without doing any of the work. In the next example, to get y by itself, we're going to have to move the 2x to the other side. And then we have to do what is the square root or the undoing exponent. So you can raise both sides to the 1/2 power or just square root both sides. What we have to remember though is when I take the square root, I'm getting rid of this power of 2. And when you get rid of an even power, you have to put plus or minus back in the problem. So if you go to the graphing calculator and you type this in, you have to type in both of them. So you have to type in the square root of 5 minus the 2x. If you look at the graph, you get a piece like that. And then when we do it again, we have to type in the negative. So now I hit negative and I do my square root, 5 minus 2x. And you can see what we would have, it's called a side, I would just say it's a sideways parabola. And so here, clearly, if we have a sideways parabola and I draw a vertical line, I'm hitting twice. So no, this is not a function. So there are a few more examples for you to look at, these DIYs. I would like you to look at them and see what you can come up with. Okay, example 3, the DIY, again, to get rid of the y to the 4th. So you'd move the x to the 4th over. Then to get rid of the y to the 4th, you take the 4th root. But that's an even power that you're getting rid of, so you have to put plus or minus back in. And again, you're running into that situation where one x is producing more than one y. So no, it's not a function. Then the next one, number 4, move the x to the other side, cube root. Here, power of 3 is odd, so we don't have to worry about plus or minus. And if you would graph this thing, it's a little bit of a sideways S-shaped curve, and you're going to be able to graph it and show that the vertical lines are fine. So it is a function. All right, so we're moving on to some function notation. Pretty easy. Just remember that this notation is not, it is not f times x. It is read f of x. And so the f is just primarily naming, it's the name of the function. It could be h for height, c for cost, and then the x is just where is telling you what the input variable is. So on this first example, it is 3 plus 2, and instead of x now, we're going to place a 7 inside there. So 2 times 7 is 14, plus 3 is 17. So go ahead and do these 3 examples, and I'll flip over to the answers. So pause the video now, and we'll flip over to the answer. So here are the examples. You were supposed to put in a 0, so 2 times 0 is 0, plus the 3, you get 3. When you put t into the function, it just replaces the x, and so you're left with a 3 plus 2t, no like terms. We can put whole equations in, or functions, other stuff. So here we're putting in x plus 4. So what we want to do is distribute the 2 through both of these. And you can see we have like terms of 3 and 8. So the final answer is 11 plus 2x, or 2x plus 11. Example 2 is kind of working it backwards. We know what the output is, 14. So we're going to take our 5x minus 3 and set it equal to 14. So now we can add the 3 to both sides, just solve a simple equation, and then divide by 5. And don't be worried that it doesn't turn out nice, but 17/5, that's a reduced fraction, so that's our answer. I would like you to look at example 3. I would like you to read the problem, see if you can figure out where your input goes, and then the question is, will the baseball clear a 20-foot fence located 280 feet from home plate? So where do your numbers go, And then I'm going to put the answer up and we'll talk about it. But just try to read it and see what the problem is asking you to do. So if we look at this example, what they're asking you to do is plug the 280 into the equation for your x's. And so if you just go to your calculator, carefully type everything in, use parentheses around the 280 on the squared, you're going to find out that the ball should be at a height of 32.12 feet. So yes, it'll clear the fence for a home run. All right, on this last example, this DIY, again, please pause the video and do the problems. Be extra careful with the negative x squared. Think about PEMDAS. You're going to do exponents first. So take the number or your input squared, then multiply by the negative, then take negative 3 times your input plus 8. So carefully write it out and see what you come up with. So pause the video now. So on the first example, you're right here, you're taking 2 and you're going to square it, and you get 4, but you have to multiply by the negative, so now you have negative 4. Negative 3 times 2 is negative 6, plus the 8, so you should get a final answer of negative 2. Part B, you have to be really careful. We want you to write the negative 3 in parentheses. So be really careful with the negative 3. You square it, that becomes positive 9. Then you multiply by the negative, and it's negative 9. The negative 3 times negative 3 is positive 9. Those two will cancel out, so you're left with just 8. Now the t plus 1, we haven't talked about FOIL or box method, but t plus 1, remember, you want to write it out so that you have 2 of them. Multiply those two together. T times t is t squared. T times 1 and 1 times t, you end up with 2t, that middle term, and 1 times 1 is 1. We'll talk more about that when we get into chapter 2. But now take this negative sign and distribute it to all 3 terms. And so this should be our final answer. Okay, the next page has some what's called piecewise functions on it. And when you look at this, I'm going to underline this one in blue. I'm going to underline this one in red. So what's happening is our function now is being split into 2 functions, and there's a rule back here, right there and right there, that tells you when to use them. So the first one, they're asking me to plug in negative 8. Negative 8 is less than 0. So that tells me when I look at the rule, I'm going to use the red function because negative 8 is less than 0. So we write down negative 8 plus 1, I get negative 7. If I look at part B, 4 is greater than 0. By rule, I should use the blue equation. So that one is simply 4 squared plus 3. So that's 16 plus 3, which is 19. And then the last one is 0, and that one is not less than 0, it's not greater than 0, but it is equal to 0. So that's the second rule again. X is less than or equal to 0. So I do 0 plus 1, which would give me 1. All right, these next 5 examples are talking about domain, and domain would be all the x's or inputs that work for a problem. So you just want to look at them. Sometimes it might be easiest to graph these things. Sometimes you just might be able to look at it and see what's going on. So in this first example, we have x minus 2 on the bottom, and we are concerned about the x minus 2. So if I set x minus 2 equal to 0, add the 2 to both sides, what I'm finding out, and you might remember from Algebra 2, is that when x is 2, it's going to make a 0 on the bottom. And we don't want 0 down there. So we would say something like all real numbers where x is not equal to 2. So you can use anything you want but 2. In the next example, it's the square root, x plus 4. And you might remember, so with the square root graph, remember we can't do anything that's negative. So if I plug something like -5,